If a fan hesitates on start or hums but will not run, you need to know quickly whether the capacitor or the motor is at fault. Start by observing the symptoms and working methodically. First, power off, and then try spinning the fan blade by hand. If the blade starts and runs smoothly after a manual spin, the start capacitor is the most likely culprit because it cannot provide the initial kick. Use a multimeter with a capacitance function or a dedicated capacitor tester to measure the capacitor value in microfarads. Compare the reading to the printed rating and allow a tolerance of about plus or minus 10%, and anything significantly lower or showing 0 indicates failure. If you cannot measure capacitance on site, a practical workaround is to swap in a known good capacitor of the correct microfarad rating and voltage and see if the fan starts reliably. Always match or exceed the voltage rating and keep the microfarad value within the tolerance range. Also, measure motor amperage draw under normal load with a clamp meter. A motor drawing noticeably higher current than its nameplate value points to internal winding problems or mechanical binding rather than a capacitor. Inspect wiring, terminals, and the run capacitor can for bulging or leakage, which corroborates capacitor failure. And remember to discharge capacitors safely before handling by shorting through a resistor rated for the job while wearing insulated gloves. When replacing parts, document the original capacitor specifications and the motor nameplate details so you or the homeowner have a clear record for future troubleshooting. Common mistakes cost time and money and frustrate homeowners. One mistake is assuming a humming motor means the motor is bad. Try the manual spin test and capacitance check first to avoid unnecessary motor replacement. Another is measuring capacitor voltage instead of capacitance, which can give a misleading reading. Use the capacitance function or a proper capacitor tester and compare to rated microfarads. A third error is ignoring motor current draw, where a failed bearing or shorted winding can cause high amperage. Measure amps under load and compare to the nameplate, and if it is high, stop and investigate mechanical or winding issues rather than swapping in capacitors. Each of these can be fixed by following the step-by-step checks I described: spin test, capacitance measurement, swap test with correct specs, and amp measurement. BigHomeProjects.com connects homeowners and contractors by making it easy to find and post about local jobs related to fan and HVAC troubleshooting, which helps people locate contractors who do the specific diagnostics you need. We also provide a discussion community where we share troubleshooting tips and experiences, and we help contractors find work by giving them a place to showcase their skills and respond to homeowner questions.